Okay, I found the on switch. Just the first thing you need to find on your robot car, the on switch. Okay, so I'm going to talk about Formula One, but I want to give you a bit of history. So about 2.5 years ago, I saw a tweet about this DIY robocars thing, and hit on Sunil Malia to go and hang out and take a look at it, and we came back and we both built the RoboRacer cars with a Raspberry Pi and the contraptions, right? We built some contraptions. So I actually built one of the first ones of those, and it did go around a track a couple of times, and then it became obsolete. The software didn't work on it anymore. So we built the donkey car versions of this. And at the time we were thinking, it'd be really cool if we could kind of use this as a hack day somewhere, maybe even reInvent. And then somehow that idea turned into 2 years ago, we did it at reInvent. And then that went so well that we ended up with DeepRacer a year ago, and now we have Evo, and this is enormous. It's just so, like, it's if you ever see something that looks cool, you like poke the good idea. Keep poking the good ideas, because if it's a good enough idea, it'll run away from you, right? So this is fantastic. I had basically nothing to do with this in the last couple of years other than turning up and going, yeah, this is cool. But the original idea can sometimes be like an inspiration to something. So the other thing I've been doing is working with Formula One. So about in the summer of last year, AWS signed a deal with Formula One to be sponsors of Formula One. We're moving Formula One from data center to cloud. We're doing machine learning. We're applying it to Formula One. We're doing aerodynamic simulation. There was a talk last night from Rob Smedley in the keynote, in the evening keynote on Monday night. A lot of interesting stuff happening. And I've spent a little bit of time at racetracks driving around my car, and I thought we could talk a little bit about what it's like to drive around the track and the way you optimize for getting maximum speed, because we think about how we're going to take these cars to the next level and what you should be optimizing for. But I wanted to start off by talking about the Formula One program. So Formula One was originally set up as a commercial entity by Bernie Ecclestone. He sold it to Liberty Media about 2 or 3 years ago, and they put it on a much more commercial footing. And they're trying to transform it. They're putting a lot more technology into the sport. So what we've been doing is working on all kinds of things: race strategies, data tracking, broadcast insights. If you watch a Formula One race, every now and again you see an AWS logo saying, hey, something about it. And I'll show you what some of those look like. And we're using a lot of AI, SageMaker in there. And, ooh, what was that? Something fell off. All right. So why is this interesting? Well, it turns out actually it's getting to near 1 billion watchers a year. This year there'll be somewhere close to 1 billion people watch an F1 race. So what we wanted was an advertising vehicle that could reach those customers, because this is one of the most watched sports in the world. It's also interesting because it's centralized. The rules and the video feeds are centrally owned by Formula One. You inject that logo, the little advert on screen, it goes to everybody that ever watches that race. It's not inserted elsewhere, so it's done at the track. So what can you learn from this? Analytics and machine learning. We get to leverage large volumes of data, real-time data streams, continuous improvement, like we have here. Are you the fastest one today? It doesn't matter if you were the fastest one tomorrow. The race is today, right? There is a check-in every week or two for the Formula One teams. They're doing 22 races next year during the year. So about roughly every 2 weeks, you get together and you see who has the fastest car and who has the best driver and who has the best operations team for putting it all together and not making any mistakes. Highly critical. Formula One ship an entire data center to the track, and a week later it can be at a different track. If you got a data center, you want to put it in a box and ship it. It's crazy. They pre-cable the track with fiber optics. They drop this thing in. It gets there about Wednesday morning, and by Thursday afternoon it's completely up and running. The whole thing unfolds. It's like a transformer thing. It sort of opens up into a communication center. There's a full broadcast studio in there where they do all the video mixing. all of the data telemetry, all of the backhaul. It's actually an amazing technological feat that you can package a pretty large data center environment and ship it around the world. Then during the race, there's lots of strategic decisions that the team are making. Should you pitch? When should you change your tires? What is the right way? What's the right time to do this? There's a lot of analytics goes into that. And finally, building winning teams. This is some of the highest paid drivers in the sport. Lewis Hamilton, I think, was on a 2-year contract for £40 million, right? Because even when his car isn't the fastest car, he makes fewer mistakes and he gets more out of the car, and they make fewer mistakes in the race and strategy, and he tends to win, and he's won the championship now 6 times. And it's an amazing achievement. It's really down to that. So what's he worth versus somebody that doesn't win when you even give them the same car? So it's worth, think about that and how you invest in the teams. Do you want to just buy cheap people and to hope that you can develop some of them, or do you want to go after the best people in the world? And it's a strategy. So what we've been working on with F1, with the insights, is overtake probability, car performance, and pit stop advantage. And I can show you some of what that looks like. So here's the pit strategy battle. What you see here is that Hamilton has pitted, so he's in 4th place, right? Vettel is in 1st place, that hasn't pitted yet. And because he's pitted, he's on faster tires, he's going a little faster on the track, so he's starting to catch up, but he's like 20-something seconds behind, and it's hard to tell, is he close enough or not? And you don't quite know how long it's going to take for Vettel to pit. And so what they did, we trained a machine learning model on all the teams, on all the pit stops, and all the tracks, and all the weather conditions and everything to figure out what this would do. And what that's telling you is that even though Hamilton's in 4th place, he's only 1/10 of a second behind Vettel predicted. So Vettel has a normal pit stop. There's a high probability that Hamilton will be right behind him or come out alongside him and catch up and overtake. So that's one piece of thing. So it makes it easier to understand the sport. You're starting to seeing a lot more sports now with on-screen graphics telling you what's happening in the sport. Here's another one. They're not on different pits, but the guy behind is going a lot faster. So this says that, yep, Grosjean is going to catch up with Giovinazzi in 4 laps. When he catches up, because he's catching up pretty quickly, it's going to be an easy overtake. Giovinazzi's tires are worn out or whatever. There's some difference that they're modeling. Sometimes it could be a hard overtake, so that's kind of another idea for modeling it. Then most recently, we have tire condition. And different cars and different tracks and different drivers wear their tires differently. Even the same tires for the same number of laps, you can get different amounts of wear. And how hard has the driver been pushing? Has he just been cruising around, in empty, nice fresh air? You're not using your tires. If you're right on the tail of somebody trying to overtake them, you wear out your tires a lot harder. And if you're driving really hard. So you can't just look at, these tires have done 10 or 20 laps. You've got to look at how they've been driven. So we modeled all of that. So how does this work? We built a machine learning model with SageMaker. This is an AWS professional services team working for Formula One. They're part of our deal with them. We're building the models with them and for them. So we have a team that's been building these. So we feed all this data into a model. Lap, sector, and within the sector times, where they finish, the gaps, the intervals, the position on the track, exactly where they are, tire compound, all of these different things, and then weather data, the configuration, all the data about overtakes. All of this went into a model, and we've got years of data. We process all that data and come up with a model and train it, and then you take 80% of the data to train, you compare against the other 20%, and you see, does the model work? It's that kind of model. Anyway, so there's a lot going on here. It's not greatly relevant to the little toy cars, but you notice I have a Pirelli hat on. I have another one of these hats that we're going to auction off. These are the hats they wear on the podium. So the other program that we have at AWS is for executives to go to Formula One races and have like an executive weekend. So if any of you you have to kind of be like sea level to get this kind of thing. It's pretty expensive, but somebody needs to go and talk to them, so I go and do like talks at these events. So, and one of the things we do is we go on the podium where they're going to be after the race, and these are the actual hats that they wear on the podium. They give us all the hats. So I have a few spare hats, and I have a hat to raffle off if anyone really wants a Pirelli Formula One hat with the laurel wreath on it for the winning car, right? So I thought I'd share that. And then I wanted to talk a bit about what it's like to do a track. So I've spent about the last 15 years, I've been doing races at tracks and autocrossing with real cars, driving myself, and I've had a few driving instructors and sort of the things. So I thought I'd talk a little bit about, what are the principles of going fast around a track in general, right? And the way I think about it, like thinking about how I'd approach it from a DeepRacer modeling point of view, I think you really need a different model for the straights and for the corners. You're in a totally different mode. Right? In the straight, you want to be on full power, and what you're trying to estimate is your braking point. Like there's a corner coming, you're trying to work out how long can you be on power before you hit the brakes. Then you want to be on full braking, and you want to slow down just the right amount to get to the next corner. So think of it as that, you're speeding up, it'll sort of gradually tail off as you hit maximum speed, and then you're braking as hard as you can. Now, that is one model. You're really trying to estimate the braking point because it's flat out and stop, and pretty much you're going in a straight line. Like you've just got to hold a straight line. So that's one model. Now, the more steering input you put in, the slower you will go. Like every time you weave, you are going slower. So if you're on a straight, you absolutely want to hold that steering as fixed as you possibly can. That's the lowest drag, the fastest way down a straight, right? It's not just that you're following a straight line, it's that you're the line of least resistance, right? So that's one thing. When you get to a corner, what you're trying to do is hold the G-force sideways. So you're trying to find a constant speed if it's a constant radius. Or what is the maximum speed that you can hold going around that corner? And it depends on the angle, right? So you're trying to just pull so that you don't slide off the track. And you've got to get the transition between the two. And at some point, as you come around the corner, you get to the point where you can put the full power back on and start accelerating. So figuring out that point. So that to me seems like it's two different models for getting in. Once you've figured out the steering model, we're all figuring out steering around at constant speed is enough of a problem. But once you get beyond that, I think those are the two models to work on. And then if you look at a track, you can figure out what's the fastest line around a track. There are points going around a corner. There's an apex where you want to hit the apex. What point in a corner is the optimal place to be just touching the inside edge of the track? And where do you want to, and you want to make it as wide a corner as you can. You want the largest radius bend is the fastest one, but you want it to be the shortest way around. So those are the kind of general ideas for getting around a track. There's plenty of videos of cars going around tracks. If you search on YouTube, my channel's full of a bunch of me doing it. And so that's one way. The other thing that's interesting, if you ever go to a track day, you can go experience this yourself. The other thing that's interesting is autocross. And autocross is usually like a featureless, like an airfield parking lot or something, just a huge expanse of concrete with a whole bunch of random cones. And you have to kind of figure out, I'm supposed to go left of this cone, right of this cone. There isn't really a track laid out with lines. You're trying to dodge around the cones. But it's typically much more agile. It's a lot more twisting and turning. It's lower speed. If you've never done autocross, it's one of the biggest adrenaline surges I've had in my life. It's like 40 seconds of going completely sideways in a car. It's crazy fun. It's very hard to damage your car. You're just like, you'll wear out tires a little bit. It's 40 seconds per run, and you'll probably do, between 4 and 8 runs in a day. And that's it, right? And then you watch everyone else do it, and everyone takes turns. It's just one car at a time with timing beams. So that's kind of closer to what we're doing here, although we've got a properly laid out track. And the techniques on autocross are similar, but some of it is just trying to get the cars to rotate in very tight corners. So that's the hairpin problem. I don't know. That's kind of what I had for content. I wanted to throw it open for questions if anyone's got any thoughts. The other stuff I do at AWS are in the open source team, so I'm interested in people open sourcing all the stuff we're doing. I also have Our open source robotics expert works in that team. So with the ROS operating system, the robotic operating system that's running underneath inside the DeepRacer, we have an expert in that, Cam Buscaron. So sort of interested in any applications people have of this whole area or questions about racing. Yeah? Yeah, the RoboRace is a full-size series. It's associated with the Formula E electric formula racing as a support race. There's a bunch of really good videos. There's a video channel on YouTube. It's fascinating. It's a full-size car with all of the extra pieces on it for autonomous driving, and the driver does a few laps to train it, and then gets out, shuts the door, and they push a button. It takes off on its own. I think they've raced two cars against each other a few times. I think once or twice it's had a crash. They've been gradually getting the speeds up. There was an interesting video of one they trained it to do donuts at one point. It's just blowing smoke out the back and doing donuts. This year they upgraded it to a more high-performance race car and announced a formula that they're going to be running, I think, through the next few months. I'm not sure if they've run the first race yet. The idea is that for the first few laps, there's a driver in the car, and then they do a pit stop, and the driver gets out, shuts the door, and they push the button, and then the second few laps, it's up to the car. And that the team has to do the software and the driver, right? So it's a 50-50 mix. So that's for the car which actually has a cockpit with a steering wheel. Then there's another car that was designed by the guy that did the graphics for Tron, and it just looks like a Tron racer. There's no cockpit, it's just wheels and a body. And that one is fully autonomous, and they're working on getting that one to the point where they'll just have a bunch of them. And if they crash, there's no one in the car. We can have probably demolition type. Probably, I suspect, we'll get some pretty aggressive driving out of these things because, they don't have to worry about G-forces and safety for the drivers. They just have to not kill any spectators around the track when the cars go off the road. But that's a really interesting. These are full-size, powerful race cars that do somewhere between 120 and 160 miles an hour right now, I think. They're all electric. Any questions? Any thoughts? Anybody want a Pirelli hat with a thing on it? Yeah. I'm happy to. We can bring up the next speaker if you want, or we can have a little break before. That's all I have. Okay, well, thanks.